All right, so I was talking about end behavior of a graph. End behavior refers to the right side of a graph and the left side of the graph. So in this one that I sketched kind of roughly here, the right side's going up and the left side's going down. You might have a graph where both the right and the left go down. So they're just asking you what's happening on this side of the graph. So there's actually a rule. When the coefficient, the leading coefficient is positive, the right side goes up. When the leading coefficient is negative, the right side goes down. So this might be a graph of y equals like 2x cubed. 2 is positive, right side's going up. This might be a graph of negative 2x squared. The 2 is negative, so the right side's pointing down. What about the degree of the function? So if the degree of the function is even, like x squared, then the two ends are like a parabola, they go in the same direction. But if the degree of the function is odd, the left side is going to go in the opposite direction. So x cubed, if this is going up, this has to go down, opposites. I think of odd and opposite as both starting with O. You need to do the leading coefficient first, because the right side gets to do what it wants to do, and then the left side just has to obey this rule. So without looking at any graphs, I can actually tell a lot about a function. So the first thing I need to do is find, am I in standard form? So yes, I am. So I'm going to go ahead and look at this term. That's my leading term. What is the leading coefficient? Positive 1. So the right side's going to go up. What's the degree? 5 is an odd number. So the left side has to go opposite what up is. So the left side is going to go down. Number 2, is this the biggest power? Yes, it is. So that's the term I'm looking at. The right end is going to go down because there's a negative right there. So now I look at the degree. 3 is an odd number. Down, opposite is up. The last one, standard form. So I'm going to look at this term right here. The leading coefficient is positive 1. So the right side goes up. The degree is 10, which is an even number. So these are going to do the same thing, up, up. This is a real brief introduction to some limit notation. X going to infinity just means the right side of the graph. And up here in number 1, we said that the right side went up. The function going up, I would just write positive infinity as up. So it says as x goes to the right-hand side, as x approaches infinity, the function is approaching positive infinity for the y values. When I look up here at number 2 for the right side of the graph, this time the right side of the graph went down. So the graph is going to approach negative infinity to go down. And again, I'm looking at the right side of the graph. It went up here. So approaches infinity. So sorry, this is kind of cut off. So this should say as x approaches negative infinity, f of x approaches what? Kind of got mixed up when I printed it. So this now is going to the left, right? If you look at the x-axis, like if this is my x-axis, that's negative infinity for x's, that's positive infinity. So as x goes to the left side, we said that the function goes down, so negative infinity. As x goes to the left side, we said the function went up, that's positive infinity. As we said, the function goes to the left up here, it went up, so that's positive infinity. Don't worry if this is kind of new notation, but we're going to start looking at limits when we go face to face. So I just wanted to introduce that to you. Okay, so this last part before we talk about turning points is just, hey, let's sketch a graph of a polynomial that fits the description. So pause the video, you're going to draw some function on here that you think has even degree and a negative, leading coefficient is positive. Sorry, this word negative should actually go over here. For some reason, formatting got messed up when I printed this. So then this one's going to be an odd degree and the leading coefficient is negative. So pause the video for a minute and I'm going to draw some examples you can look at. So pause the video, please. So here's what I drew. Doesn't mean yours is wrong. Your right side of the graph needs to be pointing up though, and then both sides should be pointing up. Maybe you drew kind of a swishy W or something, but it has to be a smooth curve with both ends pointing up. Degree is odd, leading coefficient negative, so they're opposites. Maybe you drew a linear function. That would work too. So check and see if you drew something close. So the last term about polynomials I wanted to talk to you about. A turning point is just a place where the function changes between increasing versus decreasing. So it changes direction. It might be going up, increasing. Oops, you can't see that. It might be going up, increasing, 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 turning point, decreasing, decreasing, decreasing. Or it might be decreasing, 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 turning point, increasing, increasing, increasing. So I want to show you something that a turning point is not. This is not a turning point. That's actually called a point of inflection because as I read the graph from left to right, I am increasing, 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 increasing. I'm going up the whole time, just at a different level of steepness. This is actually increasing, then decreasing. So a turning point is you're changing between increasing and decreasing. So just wanted you to check out this rule. A polynomial with a degree of n has at most n minus 1 turning points. So for zeros, when we're talking about a quadratic function, degree of 2, it might have 2 x-intercepts, but it can only have 1 turning point. A linear function could have 1 x-intercept, but it has 0 turning points. What about a cubic function? It could have 3 x-intercepts. It might have fewer, but how many turning points could it have? Only 2 turning points. So it has 1 less than its degree in turning points. So this quick exercise is to just, it's asking you what's the maximum number of turning points for each. So you want to identify the degree. So if the degree is 10, the number of turning points would be 9 maximum. There might only be 2 turning points. Let's see, the degree to this one is 3, so the maximum turning points are 2. Degree is 2, maximum turning points would be 1. Degree is 6, maximum turning points is 5. Degree is 1, linear function has 0 turning points. And these both say cubed, so it has a degree of 3, so maximum turning points would be 2. Write an equation with a maximum of 4 turning points. So we want a 5th degree. So something like y equals x to the 5th plus 9x minus 2, something like that. So 8 and 9 would be a good check for understanding to see if you understand kind of what you did today. So sketch the graph, find the x and y intercepts, determine if it's even or odd multiplicity. So what I'm going to do is I'm going to say maybe we should start with this because I want to show you in person how to find the local maximum and minimum. So I'm just going to write start with this when we come back in person. So you did not have to complete 8 and 9 today. Do not complete. So I will make a note that we're going to start by looking at this as a refresher when we come back together. You need to turn to page, here it is, turn back a page and complete 1 through 7 and just take a picture of 1 through 7 to submit today through Google Classroom. Thanks.